quadratic inequality. Part B. Case exploration method. We are going to discuss two cases or two methods in solving quadratic inequalities. The first part is the case exploration method. Before we start exploring the case exploration method, let's recall the lessons about the interval notation that you had when you were in grade 7 and graphing these inequalities. Let A and B be real numbers such that A is less than B. X is greater than A. The interval notation would be A to infinity, or from A to infinity. The graph will use a hollow dot and going to the positive infinity. For the inequality, you have there X is less than A. For the interval notation, from A to the negative infinity. And when you tend to graph this, you will have a hollow dot on A and then going to the negative infinity. Next, X is greater than or equal to A. You're going to have from A until infinity, or from A and including A until positive infinity. And then for the graph, you will use a solid dot going to the positive infinity. Next, X is less than or equal to A. For the interval notation, you will have from A and including A until negative infinity. And for the graph, you will have a solid dot on A going to negative infinity. Next, X is greater than A but less than B. You will have there AB. That means you will use hollow dot for A and B, and then answers are located in between A and B. Next, X is greater than A but less than or equal to B. This is the interval notation, and the graph will look like this. Between A and B, including B. Next, X is greater than or equal to A but less than B. You have this interval notation. Then you have the graph which shows the answers from A to B, including A. And lastly, X is greater than or equal to A but less than or equal to B. This is your interval notation. So from A to B, including A and B. The hollow dot is used in the number line if the given inequality is less than or greater than, while shaded or solid dot is used if the given inequality is less than or equal to or greater than or equal to. If the endpoint is not included, we use the parentheses in writing the interval notation. For example, 3 to infinity. On the other hand, if the endpoint is included or shaded, then we use a bracket. For example, open bracket, -3 to close bracket. The set of all real numbers can be written in the interval notation, open parenthesis, -infinity, comma, positive infinity, close parenthesis. Here are some examples. Now for the examples, we divided into two parts. First examples, direction. Write the interval notation and the number line of the following inequalities. Number 1. X is greater than 3. You draw first your number line. Next, since we are using a symbol or inequality symbol greater than, that means we are going to use a hollow dot, and we will place the hollow dot on 3. Next, since it's going to the positive infinity, or we will draw an arrow that goes beyond the positive infinity. So in writing this interval notation, as you can see, our solutions is from 3 to positive infinity. Number 2. X is less than negative 5. Draw first your number line, hollow dot on negative 5. Since we are having here less than, that means we are going to use a hollow dot. And we are going to place it on negative 5. Next, as you can see, less than is going to the negative infinity, so as our arrowhead is going to the negative infinity. For interval notation, from negative 5 to the negative infinity. Number 3. X is greater than negative 5 but less than 3. Go first your number line. Let's start first putting a hollow dot on 3, since you have there a less than symbol. Next, also a hollow dot to negative 5. Next, the first statement says it's x is greater than negative 5 but less than 3. That means our solution set is between negative 5 and 3, excluding negative 5 and 3. Next, number 4. X is greater than or equal to 5. Draw first the number line, solid dot on 5. Because we are using the inequality symbol greater than or equal to. That means 5 is included. Since we are stating values of x that are greater than 5, and these are 6, 7, 8, 9, 10, so our arrowhead will go beyond until positive infinity. So the interval notation would be 5 from 5 to infinity. Don't forget, 5 is included. That's why we are using here a bracket. Take note, we are going to use brackets if the indicated number is included. Number 5. X is less than or equal to negative 1. Draw first the number line. Next, put the solid dot on negative 1 since negative 1 is included. And numbers lesser than negative 1 are 3, negative 2, so on. So these numbers here are going to infinity are numbers lesser than negative 1. So for our interval notation, from negative 1 until negative infinity, including negative 1. Next, number 6. X is greater than or equal to negative 1 but less than or equal to 5. Draw first the number line, solid dot on 5, solid dot on negative 1, and the numbers in between negative 1 and 5 are our solutions. For our interval notation, from negative 1 to 5. There are two properties of inequalities. The first property of inequality is a product is positive when the factors are both positive and negative, or shall I say both signs are the same. That is, if AB greater than 0 or AB greater than or equal to 0. Then you have these two cases. Case 1, A is greater than 0 and B is greater than 0, or A is greater than or equal to 0 and B is greater than or equal to 0. For case 2, you will have A is less than 0 and B is less than 0. Or you can have A is less than or equal to 0 and B is less than or equal to 0. For the second property of the inequality, it states that a product is said to be negative when one factor is either positive or negative, or if the signs are not the same. That is, if AB is less than 0 or AB is less than or equal to 0. Then you can have these two cases. In case 1, you will have there A is less than 0 and B must be greater than 0. Or shall I say, or A is less than or equal to 0 and B is greater than or equal to 0. For case number 2, you can say that A is greater than 0 and B is less than 0. Or shall I say, or A is greater than or equal to 0 and B is less than or equal to 0. Take note that we are going to use property number 1 if the given quadratic inequality uses greater than or greater than or equal to. We are going to use property number 2 if the given quadratic inequality uses less than or equal to. Now, here are the steps in solving quadratic inequalities by case exploration method. Number 1. Make sure that the given quadratic inequality must be transformed into its general form. Number 2. Express the quadratic inequality into factored form. Number 3. Consider the inequality symbol in choosing the appropriate property. Remember, greater than or equal to, use property number 1. Less than or equal to, use property number 2. Number 4. Make the necessary cases depending on the chosen property. Number 5. Graph each case on a number line. Number 6. Find the union of each cases. And lastly, number 7. Make a conclusion. Example B. Solve the following quadratic inequality by case exploration method. Number 1. X squared minus 5x plus 6 is greater than 0. Step 1. Given must be in general form of the quadratic inequality. Luckily, the given is already in the general form. You have there already x squared minus 5x plus 6 is greater than 0. Step 2. Express the quadratic inequality into factored form. If we factor the given inequality, that would be x, or that would be quantity x minus 3 times quantity x minus 2 greater than 0. Step 3. Consider the inequality symbol in choosing the appropriate property. Since we have there greater than, we are going to use property number 1. Step 4. Make the necessary cases depending on the chosen property. Here we have case 1, x minus 3 greater than 0, intersection x minus 2 greater than 0. In case 2, you have here x minus 3 is less than 0, intersection x minus 2 is less than 0. And as we simplify, you will have there, for case 1, x is greater than 3, intersection x greater than 2. For case 2, as we simplify, you will have there x less than 3, intersection x less than 2. So step 5, graph each cases on a number line. So you will draw the number line on each cases. Next, combine the two graphs and get the intersection. So let's have first the first case. Hollow dot on 3 and then going to the positive infinity. Next, let's have the red graph for x is greater than 2 for case 1. Hollow dot on 2, then going to positive infinity. And when you get the intersection of case 1, that would be hollow dot 3 going to positive infinity. And then for case 2, you have already there your number line. And you have there your x less than 3 for the blue, x less than 2 for red. Let's grab first the blue. X is less than 3. So hollow dot on 3 going to negative infinity. X less than 2, color red. Hollow dot on 2 going to negative infinity. And when you get the intersection or the common hollow dot on 2, going to negative infinity. For our interval notation, you have there from 2 to negative infinity. So let's have the continuation of number 1. Step 6, find the union of case 1 and case 2. Case 1 union case 2. Case 1 states from 3 to infinity, while case 2 states from 2 to negative infinity. If we graph this one, this would be the graph. Okay, and that makes our conclusion. Therefore, the solution set of x squared minus 5x plus 6 greater than 0 is 3 to infinity union 2 to infinity, or the union of x greater than 3 and x less than 2. Again, the answer is from 3 to infinity and from 2 until negative infinity, excluding 2 and 3. Number 2. So again, step 1, make sure that the given quadratic inequality must be in the general form. Luckily, it's already in the general form. So you have here x squared minus 1 is less than or equal to 0. Step 2, express the quadratic inequality into factored form. The factored form will be quantity x plus 1 times quantity x minus 1 less than or equal to 0. Next, consider the inequality symbol in choosing the appropriate property. You have here less than or equal to. That means we are going to use property number 2. And with that, this is our cases. Case 1, x plus 1 is less than or equal to 0. Intersection, x minus 1 is greater than or equal to 0. For case 2, you have there x plus 1 is greater than or equal to 0. Intersection, x minus 1 is less than or equal to 0. And as we simplify this, case 1 we will have x is less than or equal to negative 1. Intersection, x greater than or equal to 1. For case 2, x is greater than or equal to negative 1. Intersection, x is less than or equal to 1. Or equal to 1. So as we graph this one, for case 1, x is less than or equal to negative 1, that would be the graph. The red graph is for x is greater than or equal to 1. And as you can see, there is no common or there is no intersection of these graphs. So if there is no intersection of the graphs from case 1, our result will be, or our interval notation will be, an empty set. For case 2, x is greater than or equal to negative 1. This is the graph. Next, x is less than or equal to 1. This is the graph. And as you can see, there is an intersection of two graphs. Or when we combine this would be the intersection. And for our interval notation, that would be negative 1, or from negative 1 to 1, including negative 1 and 1. So as we continue, step 6, find the union of case 1 and case 2. So case 1 is empty set, case 2 is from negative 1 to 1. So when we graph, this is the graph. And for our conclusion, therefore, the solution set of x squared minus 1 greater than, less than or equal to 0 is from negative 1 to 1. Or x is greater than negative 1 but less than or equal to 1. Or x is greater than or equal to negative 1 but less than or equal to 1. Example number 3. X squared minus 4x minus 12 is greater than or equal to 0. Step 1. Make sure that the given quadratic inequality must be transformed into general form. Luckily, the given is already in the general form. Next, express the quadratic inequality into the factored form. The given would produce a factored form of quantity x minus 6 times quantity x plus 2 is greater than or equal to 0. Step 3. Consider the inequality symbol in choosing the appropriate property. We have here greater than or equal to. That means our property must be 1. So use property 1. Next, make the necessary cases. So you have here case 1, x minus 6 is greater than or equal to 0, intersection x plus 2 is greater than or equal to 0. For case 2, you have there x minus 6 is less than or equal to 0, intersection x plus 2 is less than or equal to 0. And as we simplify case 1, you have there x greater than or equal to 6, intersection x greater than or equal to negative 2. And as we simplify case number 2, you have there x is less than or equal to 6, intersection x is less than or equal to negative 2. Next, graph each cases. For case 1, let's graph and draw your number line. So the number line there, you have there x is greater than or equal to 6. So color blue graph will tell you that from 6 until infinity, those are the numbers those are the numbers which is greater than 6, including 6. And for the red graph, will show you x greater than or equal to negative 2. And as we combine this graph, or as we get the intersection of these graphs, we get from 6 until infinity. Okay? And for our interval notation, you have there from 6 including 6 until infinity. Those are the answers. Okay, for case 2, the blue graph represents x is less than or equal to 6. And the red graph represents x is less than or equal to negative 2. And as we get this intersection or the common, you have there x will be from negative 2 until negative infinity. And for our interval notation, from negative 2 including negative 2 until negative infinity. So as we continue, as we combine case 1 and case 2, or as we get the union of case 1 and case 2, you have there the number line. So from 6 to positive infinity, and from negative 2 until negative infinity, including 6 and negative 2. So that's your number line, and then this is your graph. So from 6 to infinity and from negative 2 until infinity. So for our conclusion, we could say therefore the solutions of x squared minus 4x minus 12 greater than or equal to 0 is, so from 6 to positive infinity and from negative 2 until negative infinity, including 6 and negative 2.